I'm doing an experiment. I need 75 milliliters of 0.020 molar Ki, and I need 75 milliliters of 0.020 molar FeCl3. So what I have here, so I have the solid chemicals in their containers, and I have a balance, and I have a bunch of volumetric flasks. So even though I only need 75 milliliters, I'm actually going to make 100 milliliters, because if you look, so I've got this 100 milliliter volumetric flask, I have a 250 milliliter volumetric flask, and I have a 25 milliliter volumetric flask. And I've got an even bigger one, this 500 milliliter volumetric flask. So I can't make exactly 75 milliliters, but I can make 100 milliliters, and that'll be more than enough for this experiment. So next I'm just going to calculate out how many grams of each thing I have to put in here. So turns out, if you want to be lazy, the molar masses are literally printed right on the containers. So you can actually do the math, or you can look it up here. So if you want to do the math, just look up the molar masses off of the periodic table. The other thing to keep in mind is, so I wrote down this was FeCl3. This container says it's iron 3 chloride hexahydrate, which means it's got some waters in there. So keep in mind that's going to change your molar mass. It's a little bit heavier because of the waters. Okay, so let's go through these calculations. So I will start out with the 75 milliliters of 0.020 molar Ki. So we know that molarity is moles per liter. And we know that there is 0.020 molar, so 0.020 molar. So that's going to tell me there are 0.020 moles in 1 liter. So I don't need 1 liter of this though, I need 75 milliliters. So I'm going to change this into milliliters, so it's 0.020 moles per 1,000 milliliters. And I'm going to multiply that by my volume, which is 75 milliliters. Milliliters cancels out here, and if I grab my calculator, 75 times 0.020 divided by 1,000, so I get 0.0015. Just kidding, I lied. It's not 75 because I'm making 100. So that's actually going to be 100. You know what, I will just cross this out at the beginning, because even though I only need 75, I'm making 100. So because I'm actually making 100, 100 times 0.020 divided by 1,000, okay, 0.002. So I need 0.002 moles. And that should be the same number of moles for each, because even though they're different compounds, I was making the same volume at the same concentration. They're just going to be different masses because these have different molar masses. So I'm just going to write that 0.002 moles up in the corner so I don't forget it. And then I'm going to calculate out how many grams I need of each one. Ki, if I look this up, is 166.01, or if you want your handy periodic table, potassium is like 39.098, iodine is like 126.904, so those should add up to the same thing. So we have 166.01 grams per mole, so 0.002 moles times 166.01 grams over 1 mole. Stick that in my calculator. We get 0.33202. I'm just going to round that to 0.33. So 0.33 grams. And that was for our Ki. So now we have our FeCO3, which again, this is actually FeCO3 times 6H2O, so let me just edit that. And I still need 0.002 moles. This is 270.32 grams per mole. So if I multiply that, .54064. We'll just round that to 0.54. This is grams of FeCO3 times 6H2O. Okay, so that's the calculations done, so now to actually make these. And this is actually not too bad. So I'm making 100 milliliters of each. So I need a 100 milliliter volumetric flask for each solution. So there's the first one. Here's the second one. And then I just need to weigh out 0.33 grams of Ki and 0.54 grams of FeCO3. So let's grab this Ki. I have my 0.33 grams. I'm going to take this and put it in here. Oh my gosh, 0.33 grams is not that much. Cool. Okay, so this is my Ki here. You know what, I'll just expo marker this. 0, 0, 2, sorry, 0, 2, 0 molar. Beautiful, look at that, 0.33 grams of that stuff. Okay, so next we have FeCO3, and I just need to weigh out 0.54 grams of it. Oh, 0.5, okay, 0.54, we're good, okay. That took super long, okay. So we have our 100 milliliter flask, so I will pour this in. And then one thing to remember here, so that volume is a total volume of 100 milliliters. So that's why I'm pouring these in before I add the water, because if I were to do it the other way, to take 100 milliliters of water and then add this, it would be just a little bit too much. Okay, so there you go. It's gonna be our 0.020 molar FeCO3. I have some distilled water here, and I'm just going to add that until it reaches the line. So there is a line, if you can see it, maybe if I put in front of my sweater for contrast, that line right there. So we are trying to reach exactly this line, and that will be exactly 100 milliliters, and I'm just going to do that for both volumetric flasks. Okay, we're not at the line yet, but I'm going to swirl this around a little bit to let it dissolve, and then I'm going to add in the last bit. one thing to keep in mind here is that going under is fine, going over is not, because you cannot undo it once you've added too much. So you want to go really slow. Come on. Okay. There we go. Okay, so the bottom of the meniscus is right on that line. And then I'm just going to do the same thing for my other solution. Go ahead and swirl that. Okay, that's pretty dissolved. Okay. Oh, okay. If I get it eye level, it is just barely under. Okay, there we go. All right, so here are our two solutions. They're beautiful, and that's how you do the calculations and prepare a solution.